Computer simulation has become an essential part of science and engineering. Digital analysis of components, in particular, is important when developing new products or optimizing designs. Today, a broad spectrum of options for simulation is available. Researchers use everything from basic programming languages to various high-level packages implementing advanced methods. They all share a common virtual form of real-world physical laws. In this video we talk about COMSOL, which is one popular physics simulation software. It's a flexible platform that allows even novice users to model all relevant physical aspects of their designs. Advanced users can go deeper and use their knowledge to develop customized solutions applicable to their unique circumstances. With this kind of all-inclusive modeling environment, COMSOL gives you the confidence to build the model you want with real-world precision. Another noticeable trait of the COMSOL platform is adaptability. As your modeling needs change, so does the software. If you find yourself in need of including another physical effect, you can just add it. If one of the inputs to your model requires a formula, you can just enter it. Using tools like parameterized geometry, interactive meshing, and custom solver sequences, you can quickly adapt to the ebbs and flows of your requirements. Let's look into the COMSOL version 6. Open COMSOL by double-clicking its icon on the desktop. When the Model Wizard opens, you can start with new options. Here we have Model Wizard and blank model options. Blank option is for start from nothing, but if select Model Wizard we have 6 options of space dimension, which can be select by click, the options that you want to build. Today we do not do further about new, we will continue it in next video. If we click the File menu there are many options. Among them, Application Library is useful for beginners. There are many model of different physics field. There are many builded model example, which we can select from their model options. If we select the model, and click the Open button, in the bottom, model will appears with 3 different opening options. We can load model, with solution or without solution. Loading model takes time to load according to their size and option. If open the built-in model example, we can see model builder model settings, and model graphics windows like these. COMSOL has many user-friendly options to make simulation easy and perfect. We can customize view according to our model feature. We also talk about them on further video. Now let's introduce different window of the default view. The COMSOL desktop helps you organize your simulation by presenting a clear overview of your model at any point. The desktop is made up of several windows, which may or may not be displayed depending on the need. These windows include the Menu, Toolbar, Setting and Graphics in the top, and Model Builder, Settings, Graphics, Messages, Progress, Help, and others in the bottom. COMSOL also support different formats for import and also support to export the model. The data provided in the COMSOL web information is shown here. It support the most popular formats of CAD softwares. Here are some model examples. The solid mechanics interface is used to simulate stresses in tube connection models subjected to a series of loads. The magnetic field interface is used to model a permanent magnet motor with multiple stator coils. Sports car model based on large eddy simulation analysis for estimating flow-induced vibrations. The diluted species transport interface is used to solve mass transfer in a plate reactor model that accounts for convection and diffusion. A complete vibroacoustic analysis of a loudspeaker is simulated using a hybrid BEM-FEM approach that combines multiple physics. The electromagnetic waves, frequency domain, interface is used to model the electrical performance of cavity filters. The LED bulb model uses the solids and fluids heat transfer interface to describe conduction, convection, and radiation combined with non-isothermal flow. The lumped battery interface is used to define a battery pack based on a set of lumped parameters that can be used to calculate a temperature profile. Electrochemical forces multi-physics coupling combines solid mechanics and electrostatics interfaces to simulate surface micromachined accelerometers. The geometric optics interface is used to model the propagation of electromagnetic waves with the Petzval lens model. A packed bed latent heat storage model is simulated to include phase changes and heat transfer effects with local thermal imbalances. The soliton collision model uses a general form parade interface that provides the flexibility to specify the parade in a general form. Helicopter blade stresses and deformations induced by rotation and applied dynamic lift are analyzed using a multi-buddy interface and eigenfrequency analysis. The electrostatic field around the COMSOL lens model is computed using the Electrostatics Interface, and the particle trajectories are computed using the Charged Particle Tracing Interface. A topology optimization function is used to study the optimal material distribution in a hook subjected to two distributed edge load cases. Uncertainty quantification module to obtain the Sobel exponent of the bracket model. A model of two separate fluids at different temperatures flowing through a shell and tube heat exchanger. Induction hardening simulations can be performed using the temperature of the steel billet during induction heating. There are many more models, we discuss them later. Stay looking to the next videos.